thank you very much for being here. I know, basically, I'm the only one standing between you and Nick's talk, so I'm going to try to be quick. Where's the clicker? So my talk is all about how can we make operational change easier, or at least develop the mindset that we should make change easy, because it's a good thing. My name is Henrique Rodrigues. I am the lead DevOps engineer at Reevoo. We're basically a trusted third party for ratings, reviews, and customer-generated content. I'm a huge GNU Linux nerd, and you know that I'm a nerd because I use GNU in there. And people might have heard this joke before, so sorry. That's my email if you want to reach me out. And I use email, not any of the other stuff. And I only know how to make presentations with bullet points. So, change. Change is huge because this first quote that I have here, unfortunately, I don't know where it comes from. I remember reading this quote, I think maybe on Slashdot or something, and this was the whole reason that brought me to put out this presentation for you. So if you only have time to add a single feature, work on the auto updater, because then if you have any other idea, the auto updater will take care of it to deliver value in the sense. So if you've worked with me, if you know me, you know that I hate that word value and the way it's applied, so I'm going to make some cosmetic changes. Yes. I prefer to think of value as not in terms of business, because for business, value is only a feature. Your code may be riddled of bugs. Fixing those bugs is not value. All right? For me, it is value. And that's what you want to do. You want to add more features, and you want to fix some bugs, apply some security patches. That all adds value to the platform. So it's easy to change. We've got lots of technology that we can use. We use source control, and we use Puppet, and God help you if you use Chef. Package management takes care, Package management takes care of maintaining and updating, and it's wonderful. We all love these technologies. But in reality, you've seen this happening. You've been in the industry. You have pull requests that stay on in GitHub for months, for years, right? You've got, and this is very common, you've got like Puppet or Chef rules that are never applied because you don't automatically push those changes to production. And package management that you say, oh, I'm using Linux. I don't need to restart ever. So you update the version, but the old code is still running. So you are vulnerable. So change is not about technology. Technology can make things easier, but you got to think about processes. And you got to think about losing the fear of change. And the last quote that I have here, if you have to think twice about deploying or applying configuration changes, your processes are wrong. Because you should just know that you can apply it. Have no fear. I remember back in my previous company, on a hack day, we decided, let's implement continuous delivery. And I was very scared, because continuous delivery means that if you do any change that you make, it's going to be live in production. There's no QA or anything like that. In reality, the pipeline that we've built was a little bit more complex than that. You could request some features to go on QA before going live in production. But in reality, we implemented CD in a hack day. And it works all to this day. It's fine. no problems. And if you have problems, you fix them, and CD will put it alive as quick as possible. So at Reevoo, when I joined, I had one idea in mind, which is change. We need to make sure that we can apply change. We can deliver value. So we wanted this kind of stuff. We wanted an infrastructure that was replicable, so we could just spawn a new one if we needed. So for example, if you wanted new staging, just create a new staging environment. Self-healing, because I don't want PagerDuty to wake me up. And auto-updatable as well, because I don't want my CEO to wake me up and say, why are you on the news? And of course, this is for developers as well, because my goal as a system administrator is to enable developers to do whatever they want in a reasonable kind of way. This was a technology stack that we chose. We evaluated a couple of options. AWS, we already ran stuff in AWS, so no-brainer there. Ansible, no-brainer there. CoreOS is a really interesting piece of technology. I don't know how many of you guys know or use CoreOS? Good stuff. Kubernetes, industry standard. I've used Mesos before. I like it. If you use Mesos, all fine. If you're building something new, Kubernetes is probably worth it. Docker, of course, and we also run Rocket in production, which is nice. Jenkins, really good. So all of these technologies, industry standards, choose any other. I really don't care. I'm not biased. Yes, I am. I'm biased. You probably have noticed. I love Jenkins. Love it. Now, why? So I'm not trying to preach to the choir. We know that containers make life easy for everyone, really. And there are different ways that you can use containers. But most importantly, you don't need Kubernetes, you don't need Mesos or anything like that. You don't need Swarm to use Docker. If you're on an old infrastructure that you deploy with Capistrano and you have one machine with one service, you can still use Docker. Just instead of using Upstart or systemd to start your service, use Docker Run. It's fine. And you'll see the benefits that you get. They're amazing. CoreOS, the reason we chose it was the auto-update mechanism. So it's a really slim Linux distribution that the only thing it does really is run containers. And it comes with an auto-update mechanism that kind of guarantees that you won't get failures. So it updates to a different partition and then reboots, and then if it's a problem, it will roll back. It's based off Chrome OS. They use that mechanism as well. So this kind of guarantees you that whenever there's something new, a new patch, the whole thing will just restart and you'll be in a good state. We use CoreOS with immutable infrastructure, basically using AWS's user data. We pass everything there, and it's nice. And it also means that you're not bound to old rules. For example, maybe if you look into infrastructure, you'll see some users that actually haven't been in the company for like 7 years. This guarantees you won't have that. Kubernetes in AWS, if you do it properly, almost everything can die except etcd, and you'll still recover. And if you do things really, really well, even etcd can die, and you're still fine. One of the things I want to mention, going back with AWS, is one of the problems that we hit was the 16K limit. I just want to put it out there. The way we solved it was we basically put the user data on S3, and then user data that we pass to the machine is a really small config that just fetches from S3. And they have added this capability a couple of months ago, and it was really helpful for us. Jenkins, a lot of people see Jenkins as this old piece of technology built in Java, and of course, if it's Java, it's bad. But have you guys seen Jenkins 2 and Blue Ocean? Really awesome. Especially if you combine it with the new pipeline from Jenkins. Basically, everything is code. You write some Jenkins file in your repo, and then you tell Jenkins, scan all my applications in GitHub. And he will find all repos, all branches in repos that have a Jenkins file. He will bring it in without you having to do anything, and it will build it. So you don't need to click any more buttons to add a new application in Jenkins. Everything happens automatically. Developers really like this. Helm is a new product coming from, it was incubated by Kubernetes. And they say it's like a package manager for Kubernetes. I half agree, but you can consider it to be a tool that basically gets some templating for Kubernetes, some values, mix them all together, and you have your application running. So if you want to change, say for example, the version of or the image or anything else, you just change the values file and the rest will be there. It's very useful if you're trying to shove stuff into Kubernetes that you haven't built yourself. There's no, don't try to reinvent the wheel. Kubernetes Helm has a huge amount of charts, official ones. Just use those. And also, mostly important, this is really good. So if you have not one production infrastructure, but multiple ones, then if you apply something and it breaks, and it will break eventually, you're still fine. Then you just need to fix it. And this is one of the things that I'm mostly proud of going to implement in the future. We don't have it yet, but we will. So Jenkins pipeline, we decided we don't want developers to write their own Jenkins files. They can be very tedious. But luckily, Jenkins allows you to have some shared configuration. You just put it in a Git repo, and then you tell Jenkins to use that Git repo for the shared functionality. This is the example. This is a complete Jenkins file, and this is what we use on our applications. This is the only thing that developers need to write, and their application is now live on Jenkins being tested. And then the YAML file with the values. So trying to be a bit dramatic. What our shared pipeline does is we use multi-stage builds, which are kind of a new feature in Docker. If you don't use them, you definitely should, because it basically means you can, for example, in our case, we build images for testing purposes to run in CI, and we have production images. Test images can be big, can be huge. I don't care. They can be 5 gigabytes. As long as they run, I'm fine with it. Production images, they need to be really small, with reducing the attack vectors as much as you can. But you can, one thing you can do is you can copy artifacts from one image to the other. So for example, if you test everything in your test image, you can just, if you build the artifacts already, you can just copy the artifacts. You don't need to have another Docker file where you install all the dependencies that you need. You can just copy those. You can do really smart stuff with that. If you want, come to me later. We have some really good ideas. And then, of course, we test everything inside a Docker container, because why shouldn't you? And we deploy to Kubernetes, if you want. You don't want to deploy everything. So, like I mentioned before, you have a Jenkins file that enables Jenkins to recognize a project. And then we have a YAML file which has some variables, like for example, what is the service name, what tests you want to run, like a shell. You can just have an array with a bunch of commands, and that will tell you with different pipelines, and they all run in parallel, tell you if is the application good or bad. With Helm, it's kind of the same thing. Building Helm charts is a major pain. If you have to do it for, let's say, 30 applications, I wouldn't recommend it. So our approach was, and once again, this is our approach, you think about what's best for you. Our approach was to build a single Helm chart that accounts for everything, basically. So the template is a bit complex, but it works. We use the same YAML file as before, and we can specify environment variables, the Kubernetes objects, anything we want to put in there, really. And this will, Jenkins pairs those and runs the Helm charts and deploys our application. So you really don't need to have all that boilerplate code. We went to with that approach in the beginning, but it's really easy to make mistakes. And having mistakes makes things hard, and we want to make things easy, change easy. So I know this was a bit out there, but basically what I want to describe is there is a way, or there are ways to make things easy for you. So enabling change is key to success. If you don't have change, you die. You don't have anything else that distinguishes you from someone else, some competitor, for example. You have to rethink your processes and make sure that what you're doing is the right thing for you. Fear cannot hold you back. But making change easy is not necessarily easy. You might, for example, in our case, our Jenkins pipeline, it is a bit complex. But then it puts the burden of maintaining that on us. And developers can do what they do best and just add value to the platform. It's very rewarding. I've seen the other side. It's very green. It's really good.